What up, guys? Not too many of you seem to be watching my videos, which is unfortunate since I spent all this time doing it. Whatever, here I am again, about to do this worksheet for you guys. Basically, the way that these logs work is, like, if you take the base, right, this is called 2, right, let me focus in here. If you go 2 to the 3, that equals 8. 5 squared is 25. 3 cubed is 27. 10 to the 4th, right, is 10,000. So that's kind of what you want to use. You want to use this like kind of snail approach and then kind of work backwards. So this one is 5 cubed equals what? So x must be 125. And then what to the 4th power is 81. So x to the 4th power is 81. That one you can do the 4th root, so x is the 4th root of 81, which is 3. This one, 10 to the 100 to the what is 10. Okay, so since you have a big number to a power equals a smaller number, then that must mean that this exponent is kind of a fraction, and that must mean it's some type of root. So what root of 100 is 10, right? The square root of 100 is 10. So 100 to the 1/2 is 10. So x is 1/2. And then here, what to the 5th power is 243. So basically the 5th root of 243, which is 3. And then here, what to the 10th power is that? That one you'll have to use your calculator. You'll have to do the 10th root of 0.001, and you get... So to do that on your calculator, you press the math button, and then you pick 5, which lets you pick what kind of root you want. And then you want the 10th root, and then 0.0001, and then you get 0.5011. Okay, so what are the domain and range of this function? You want to solve for y first. You get y equals 2 to the x minus 3. So you graph this function. It's good to start with the 0. So because it's minus 3, you're going to have a horizontal asymptote here at the -3. So go ahead and draw that. And then 0. So 2 to the 0th is 1. Minus 3 is -2. 2 to the 1 is 2. Minus 3 is -2. 2 squared is 4, minus 3 is 1. 2 cubed is 8, minus 3 is 5. 2 to the 4th is 16, minus 3 is 13. So I think that's all that can fit in here. So 0, -2, 1, -1, 2, 1, 3, 5, 4, 13. And then you get this graph here. The domain is all real numbers, and the range is greater than -3. This has no line of symmetry. And x and y intercepts, to find the y-intercept is easy, right? That is 0, -2. To find the x-intercept, you're going to want to use your calculator. So you graph it. 2 to the x minus 3. Because obviously, right, it's obviously intersecting here in between 1 and 2. And you can see that here. So you want to find that. So you press second trace, and then you want to pick 0, which is another word for x-intercept. And then left bound, you want to go to the left of your x-intercept. Right bound, you want a little to the right of your x-intercept. And then guess, you move it as close. And there you go. Get your 0 is 1.584. So your x-intercept is 1.584. Okay, so sketch the inverse of this function on the same set of axes. What are the domain range? So if you have this is your horizontal asymptote, then when you have your inverse, it's going to be your vertical asymptote. The domain and range switch, right? So if your domain was all reals, now that's your range. And if your range was greater than 3, then -3, then now that's your domain. And then your x and y value switch. So instead of plotting 0, -2, you're going to plot -2, 0. You're going to plot -1, 1. Then you're going to plot 1, 2, right, you flip these, 5, 3, and 4, 13. And then you get like this graph. Then the x and y-intercept is switched. So your x-intercept is now what was your y-intercept. Your x-intercept is -2, 0, and your y-intercept is 0, 1.58. Right? They switch from here. Okay, and then for a circle with a radius 12 centered at -2, 3, right? Here's your formula. So remember, it's the opposite. So it's x plus 2 squared plus y minus 13 squared, and then equals your radius squared. So 12 squared is 144. Circle with center -1, 4. So it's x plus 1 squared plus y minus 4 squared, and then the radius squared is still 1. And then here you just want to move your things over. So you move your -6 and then leave room to complete the square, plus y squared, leave room to complete the square there, and then move this over here so it becomes -57. And then when you complete the square, you get 9, and then divide by 2 squared, 64. And then what you add here, you have to add there. So to add 9 and 64 here, and this becomes x minus 3 squared. This is y plus 8 squared. And then you get -16. There you go. Okay, last problem. Says when you stack one function machine on top of another so that the output of the first machine becomes the input of the second, you create a new function, which is a composition of the two functions. So the first function is f of x and the second of g of x. The composition of function can be written as. So the function machines here are stacked as shown. If x is input at the top, what expression comes out the bottom? Okay, so g of f of x. Basically, you want to plug f into g. So f is x squared minus 1. So you want to plug that in where x is here. So it's going to be 3, and instead of x, you want to write x squared minus 1 plus 2. And then that's 3 x squared plus 1, and then all you do is simplify. And that's it. this problem, I said there's a typo. You're supposed to go the other way around. So now we're trying to put g into f. So you want to put, instead of x squared, we're going to do this whole function, 3x plus 2 squared minus 1. And then it's helpful to just simplify this to 3x plus 6. And then you want to use your area model here. So it's 9x squared, 18x, 36. So then it becomes 9x squared plus 36x plus 36 minus 1. So our final answer is 9x squared plus 36x plus 35. Alright, that's it. Hope you're having a great day. Can't wait to see how you're doing on your quizzes. Alright, thanks. Bye.